What is high-performance computing? High-performance computing, or HPC, is a technology that allows us to process huge amounts of data and solve large, complex, and parallel problems at very high speeds. HPC is behind the scenes every time you use Google Maps to navigate, or when checking the weather forecast for your area, whenever you watch a blockbuster movie from the big studios with incredible special effects, whenever you hear about groundbreaking research on COVID-19. Here at Wake Forest University, our HPC presence is embodied by the DEAC Cluster.
The DEAC Cluster is Wake Forest University's high-performance computing solution, offering free, robust compute resources to students and faculty for the Renolda campus. What are compute resources, you might ask? Those are the components within a computer that enable users to load data, crunch numbers, run computer programs, and generate results. The components offered on the DEAC cluster include nearly 4,000 compute cores and 19 terabytes of memory. By comparison, the average laptop offers only 2 cores and 8 gigabytes of memory. So you could say it's like having the power of 2,000 laptops at your fingertips, with everything configured by the HPC team to work effectively as one system and run efficiently to maximize results. One way the HPC team configures the cluster to run efficiently is through the use of the Linux operating system with a simple command line only interface. Linux is designed to have low overhead, so all of our compute resources can be dedicated to our users and their research. And who are those users? Well, they can be found all over campus, including undergraduate and graduate students, postdocs, and faculty. The DEAC cluster provides support for users across 14 departments at Wake Forest University, connecting them all through their use of high-performance computing.
My name is Lowman, and I am an assistant professor in the Department of Engineering. My research focuses on understanding how ecosystems respond to extreme events.
My name is Kefer. I am a senior studying computer science, neuroscience, and statistics at Wake.
My name is Sam Cho, and I'm an associate professor in the departments of physics and computer science.
My name is Ilse Schaeffner. I'm a senior biochemistry and molecular biology major studying protein structure and function.
My name is Ron Thompson. I'm a faculty member in the School of Business here at Wake. I teach in our working professional MBA programs and also in our Masters of Science in Business Analytics program.
As you can imagine, with users from 14 different departments, the DEAC cluster hosts a wide range of research topics, from material science and molecular dynamics to biomedicine and injury mechanics.
My research involves understanding how ecosystems respond to extreme events like hurricanes, fires, floods, droughts. And so with that, I do really large numerical models that require high-performance computing. So the cluster makes my research possible.
My computational biophysics research involves performing molecular dynamic simulations. These simulations of biomolecules, such as proteins and RNA and DNA, they can tell us how proteins jiggle and also move, but also how they sometimes fold, sort of like origami, into very complex shapes. They're very important for developing anti-cancer drugs and to help us understand how to prevent diseases such as Alzheimer's, ALS, and Parkinson's.
My research project studies the effects of various point mutations in the novel coronavirus spike protein, namely the conserved glycine residues in the receptor binding domain. And my interest is to see how these various point mutations will impact the binding efficacy and the binding energies when in complex with human ACE2.
Each area of research and software also requires some variety of compute resources to run on, including CPU cores for calculations, memory for large-size computations, and disk storage for retaining relevant data. The HPC team maintains all of the hardware that provides these resources, eliminating the need for our users to worry about troubleshooting, upgrading, and configuring their own system. With the hardware and software provided by the DEAC cluster, researchers have the ability to run multiple computations at once, sometimes by the hundreds or thousands, with no need to be in front of the computer while they run. The DEAC cluster has been enabling users to work remotely for almost 20 years, long before Zoom or Google Meet were being used.
I've used the DEAC Cluster for the many softwares that it provides that I would not be able to install on my own laptop. I also use the cluster to run my simulations that would normally take days to weeks on my laptop, and they take minutes to hours on the cluster.
The HPC team was really important in providing the know-how for us in terms of the actual high-performance computing components of what we did. We all came into it with some kind of understanding and some CS background, but really the specifics of running HPC tasks was really something we had to draw on the HPC team for.
The way we work with the HPC team is that they've done a great job of setting up a series of instructions for the students in how to complete the assignment. They've also created some instructional videos, and more importantly, they come into the classroom either on ground or virtually in a Zoom meeting to interact with the students. They start off by explaining what the DEAC cluster is, why it's used, how it's used, and then they go on to troubleshoot with the students as they're working through the assignment. And all the students end up actually completing the assignment.
The HPC team has been instrumental in getting my research up and running, especially with my large data needs. They've helped me with all types of cloud and both physical data storage solutions. And they also help my students get up and running, especially for those students who are new to using Linux and Unix systems.
The DEAC Cluster's primary mission is to support education and learning at Wake Forest University. In addition to research support, another way the HPC team accomplishes this is through supporting classroom learning.
Our students take a high-performance computing class. In this class, with the help of the high-performance computing team, the students learn Linux administration. They also learn software installation and optimization. They also learn software engineering skills and presentation skills. These are, of course, very important skills that will set them up for very successful careers in academia or industry.
And another fun way that I've used the DEAC cluster is in a numerical methods class that I teach. So the students have access to the DEAC cluster and get to compare how quickly their code runs on the cluster versus, say, on their own laptop.
All of our students are required to complete a final project with the real client. And some of those clients provide the students with large data sets that they can't process using their laptops. And so once again, they are required to use the DEAC cluster. This actually gives the students an advantage when they go out in the job market. They can rightly state that they have worked on an assignment with the Unix environment and have also worked with large data sets. So overall, the partnership between the business school and the HPC team has been great. I've been very happy with the results, and so have the students.
So that's how HPC is done here at Wake Forest University. We hope this brief overview has shown you that HPC is certainly more than just fast hardware and number crunching. HPC is our work, our team, our users, and our institution. HPC is about building connections.